Okay, what I need you to make sure that you do is you know these two charts. And I told you that that's what I expected you to do between last period and this period. Make sure you know those charts. When the velocity is positive, what does that tell us about the particle? When velocity is positive? Yeah, increasing means going to the right. A velocity that's negative means the particle's motion is decreasing, which means going to the left. The velocity is 0 or undefined means it's possible that the graph is, or the particle is changing direction. If the velocity changes from positive to negative, then the particle changes from going right to left. We okay there? All right, let's go down and remember acceleration. I might make one. 0? Because it says possible. Possible. All right, let's talk about acceleration. If acceleration is 0 or undefined, then what do we know about velocity? The velocity may change sign, right? If the acceleration is positive, then the velocity is increasing. Acceleration negative means the velocity is decreasing. And then if the acceleration changes from positive to negative, velocity changes from increasing to decreasing. Okay, so let's go on over here to the graph. Woohoo! Please notice this is position, but Sparks uses S of t this time for position. Sometimes he uses P of t. Physics uses S of t. So that's why calculus uses S of t. I don't know why physics uses S of t, but they do. Okay. Now please remember that the particle itself is not going like this. The particle itself is moving horizontally. So the particle might be going like this, but it's moving horizontally, okay? If the velocity is negative, then the particle is moving to the left. If you go back, if velocity is negative, then the particle, the function would be decreasing, which means the particle is going to be moving to the left. All right. At which points is the velocity equal to 0? Now remember, this is position. Why B and D? Because they are relative extrema, aren't they? What happens to the position at those relative extrema? Changes direction, right. So here's what we know. At B and D, and it says to justify your answer, because the particle changes direction. We need to say it in the context of the problem. Yes, they are relative extrema, but what does that mean in the context of motion? At which points does the acceleration equal 0? What? C, because that's where you have a point of inflection. Yep. And I probably should be writing at t equals c, because you have a point of, but I don't know what happened. You have a point of inflection. If acceleration is not changing, it means you're on cruise control. Right. Thank you for physics. Okay. On what intervals is the particle's velocity positive? If velocity is positive, go back to your thing. If velocity is positive, so that means the position function is increasing. Where is the position function increasing? Now let's talk about how to write that piece. That piece is easy. Where does this piece start? X value. X value. This is, remember, t is time. 0. T is time. So 0 to B. Did you say that, Avery? I didn't hear you. Talk louder. On this section, on position, velocity, acceleration, you talk real loud. 0 to B and where? D to infinity. There you go. D to infinity. Because S of t is increasing. Continue. At what intervals is the particle's velocity negative? Why between B and D? Because S of t is decreasing. From B to D, because S of t is decreasing. On what intervals is the particle's acceleration positive? Now, think about this. If the second derivative is positive, what do you know about the function? Concave up. Where is this function concave up? C to infinity. S of t is concave up. I really need to team teach this unit with Miss Carter. On what intervals is the particle's acceleration negative? Why 0 to C? 0 to C because S of t is concave down. Now, Sparks has 5 commandments of particle motion. Moses brought these down too. They were just behind the real important ones. Okay. Now, this is horizontal motion. Okay. He just had a third small tablet in his pocket. Okay. If the velocity is positive, the object is moving to the right. Now you're okay with that. I will have all of these listed here when you get back, so you can just come back in and write them down, okay? You about have these written down? Almost. I want you to get that paper, a picture of speed, out. Listen, we got to get through the rest of this lesson today. This class ends at 2:05. Does anybody need more time to write? Speaking of your car, go to this sheet. This one, this has a picture of speed. Now, we're going to go through this, and then I'm going to make myself look like an idiot up here, probably over there I have more room. Because somebody showed me this once, and it just made sense to me. So let's go through this picture of speed, because I just got this from a calculus workshop I went to last fall. All right. Students often benefit from a verbal explanation of all this. Picture a car moving along a road going forward that's in the positive direction, okay? Since it's going forward, the velocity is positive. Now look at the first bullet. If you step on the gas, your acceleration pulls you in the direction you are moving. Do you buy that? Therefore, you speed up. If your velocity is positive, you are moving forward, and you are being pulled in the direction you are going, your acceleration is positive, therefore you speed up. If your acceleration and velocity are both the same sign, if they're both positive, you're going to speed up. Does that make sense? Let me just make a fool out of myself as I go here. For those of you who are watching the video, well, you're missing the, well. Okay, so I'm moving forward, so I'm going to be going to my right. Acceleration is like a pull or a push, okay? Help me here if I mess this up. So I'm going forward, I'm going to the right, and I accelerate. So I'm being pulled in this direction. I'm speeding up.
So like walking to jogging.
Yeah, essentially. So my acceleration is positive, my velocity is positive because I'm moving forward. My acceleration is positive because it's pulling me in that direction. So I'm going faster, I'm speeding up. Going forward, I'm speeding up.
So like, if the acceleration is like, so the acceleration is not zero, then you're increasing your velocity exponentially.
If your acceleration is not zero, you're on cruise control with a constant speed.
So like, if you're, say like your acceleration is 2, so you constantly increasing at a rate of 2, or is it like exponentially increasing?
It would, well, if my speed is if my velocity is 50 miles an hour, and I am accelerating at 2 miles an hour each hour, then it would be 52 miles, and then 54 miles an hour, and then 56 miles an hour. It's a constant rate of change. Now, let's go to the second one. Going too fast is not good, so you put on your brakes. You now accelerate in the opposite direction. So I'm moving forward too fast. So my acceleration is going to push. It's going to push me backwards. I'm still going forward, but I'm doing what? Going forward slower. Yes. So if my velocity is positive and my acceleration is negative, I'm being pushed, then I'm slowing down. So let's take a look at that second one. It says if the velocity is positive and acceleration is negative, you are slowing down, so your speed is decreasing. With me so far? The third one. Finally, you stop. You shift into reverse. You start moving backward, which means a negative velocity. So I'm going this way. I'm going to the left. I'm going backwards. I'm in reverse. And I speed up going in reverse. So what's happening? I'm speeding up, right? No, my acceleration here is negative because it's pushing. It's pushing, it's not pulling, it's pushing. So if my velocity is negative, I'm moving backwards, and my acceleration is pushing me backwards, then I'm speeding up in the negative direction. So if my velocity and acceleration are both negative, I am speeding up in the negative direction. The same thing. Let the car be the particle. We are moving, all we're doing in Cal 1 is horizontal. We are not making turns, loops. We are going horizontal, back and forth. Yes. Now, look at the last one. Then you put on the brakes. So the acceleration's in the positive direction. See, if I'm going backward, so my velocity is negative, right? and I put on the brakes, what happens?
Velocity.
I'm being pulled that way, right? So I'm slowing down to eventually stop. Okay, you put on the brakes, so your velocity is negative, but your acceleration is positive. That makes you slow down. If the velocity and acceleration have opposite signs, you are slowing down. If the velocity and acceleration have the same sign, you are speeding up. You're going to forget what I just told you. So help me to goodness, you're going to forget it. Because I will be asking you, given certain parameters, is the speed of the particle increasing or decreasing? And all you're going to look at is the velocity, or all you're going to look at is the acceleration. You have to look at both of them. Question?
If you go in a car, right, like you're saying, you're going in reverse, so the acceleration is decreasing.
Okay. Let's see what we can do here. Suppose the velocity of a particle is given by this function for t greater than or equal to 0, where t is measured in minutes and v of t is measured in inches per minute. Answer the questions that follow. All right, we want to find the value of v of 3 and v prime of 3. How are we going to do it? By golly, I'd plug that into y1. Sure as anything, I'd plug that thing into y1. Velocity is always position over time. So centimeters or a length over time, inches per minute. So this tells us that particle, it says to describe the speed. Oh, I don't know how to describe the speed yet. Because in order to determine if speed is increasing or decreasing, not only do I have to know the velocity, I have to know the acceleration. So let's find v prime of 3. But v prime of 3, oh my goodness, that's a of 3. So you're going to have 119, and that's going to be inches per minute per minute. So every minute, the velocity is changing at 119 inches per minute. So let's talk about speed. Why is the speed increasing at 3? Right. So since v of 3 and a of 3 have the same sign, the speed of the particle is increasing at t equal 3. Please, if it asks you speed, you got to know velocity and acceleration. Questions? Go.
I might have done this wrong, but velocity, speed, action, and acceleration.
Right, we're on B. On what interval is the particle moving left and right? What? Aha! I'm going to do a sign analysis of what?
You should use a critical number because you have to find the derivative.
Of what? A particle, look at your tables, look at those charts. A particle is moving to the left when it's, no, that's not what I asked. A particle is moving to the left when its velocity is negative. So all I need to look at is I need to do a sign analysis on the velocity.
Oh, so not the
Mm-mm. I want to know, when is this thing moving left? It's like, when is this function decreasing? Well, the function's decreasing when its derivative's negative. So just look at the derivative of position, which is velocity.
Oh, because we're not starting from S of t or P of t.
Right.
We're starting at B. Okay.
So, all right. V. What are my critical numbers on velocity? Which means on the interval I am given, I don't have any critical numbers. Correct?
Yeah, because it says negative.
So here's, I know. So here's what that means. Here's what that means. This is the only place I'm going to look, and I only have one piece because I don't have any critical numbers on that piece. So what this tells me is that the particle would be moving either to the left all the time or to the right all the time. Because I don't have any critical numbers.
Yep. So it doesn't change.
Because my critical numbers are -2 and -4, which are not on that interval.
You never changed time check.
So if time is the x-axis, what's on the y-axis?
Well, it depends. If you're doing position, then it's like the distance away from where you start.
What is velocity?
Well, look here. Look on the. Oh, I didn't give you any. If it's velocity, then it'll be. Okay, let me say this. If it's position, then that's going to be a length measure, inches or feet or miles. If it's velocity, then that's going to be like inches per minute or feet per second or miles per hour.
Oh.
Okay. Are we still on this page? Okay. So what we're going to do is we're going to pick a number in this interval. 5, 2, 1, I don't care as long as it's positive. Infinity is not a number. Does 2 make the velocity positive or negative? So what do I know about the movement of this particle all the time? This particle is always moving to the right. It doesn't matter. It doesn't matter. I'm going to say for t greater than or equal to 0. The particle is always moving right. Because v of t is positive. Okay? Now, folks, all we've got left is AP problems or modified AP problems. So sometimes, like on this first one, Sparks took it and just changed it up a little bit. So this is a version of the 1998 AP Calculus exam problem number 3. This will answer your question. The graph of velocity in feet per second of a car traveling on a straight road. Huh? Just a minute. Look, we said this is in feet per second. Look here. There's your time. There's your velocity in feet per second. I started to show you this earlier and then I changed my mind, but I'm going to do it now. If this is a position graph, and this would be your time, and I'm just going to say seconds, and this would be like feet, your distance. What if I do this and this? That'll be feet per second, okay? Now look here. What if I do this and this? That's feet per second. So, yeah, okay. know, I feel, I know, I feel you, I feel it. A table of values for v of t at 5-second intervals is also shown. So this is the same particle, okay? Same particle, all right? During what intervals of time is the acceleration of the car positive? Acceleration is positive when, no, acceleration is positive when the function is, no, okay, go back. Second derivative is positive when the function is concave up. Second derivative is positive when the first derivative is, so acceleration is positive means the velocity is increasing. Right? Okay. So what I'm looking for is I am looking for acceleration is positive when velocity is increasing. You with me? When does that happen? This is a graph of your velocity. 0 to 35, is that it? And 45 to 50. So 0 to 35 and 45 to 50. Do you understand that? I just have to keep going back. Acceleration is second derivative, velocity is first derivative, and I can keep things straight that way. All right, find the average acceleration over the time interval 0 to 50. Go back in your notes. This set of notes reminds you how to do average acceleration. Go back and look. That's right. Average acceleration is v of b minus v of a over v minus a. Grab your calculator. Oh, mercy. Gotta find 50. You do know that you can go to your table set and start the dang table at 50 if you wanted to, right? So that's how you could use table instead of having to scroll through the whole thing. Huh? Forget what I said. I'm an idiot. I was thinking about the last equation we were working with. Golly. Can you tell that I get stressed a little bit? What's v of 50? 72? I don't even know. I don't know. Okay, over 50. So 72 over 50. Now listen. Okay, 36 over 25. On the AP exam, you can leave it right here. That's beautiful. No, you cannot leave it like this. Yeah, no. You can't, no, you cannot leave it that way, no. Now, what is our unit on this average acceleration? Feet per second per second. Okay, per second per second. Find one approximation for the acceleration of the car at t equal 40. I am trying to approximate a of 40, which is v prime of 40. How can I approximate, though, because I do not have an equation? Secant, so what would I use? It's better to do the slope of the secant line off the table. I do not have I have the velocity at 40. I don't have the acceleration at 40. So tell me, how can we approximate the acceleration at 40 from the table with a secant line, you guys said? Yep. Yep. So V of 45 minus V of 35? To Ransom and Wendy? We'll be all right. I'm just an idiot sometimes, but you know that already. 45, 60 minus 81, is that right? Over 10. Negative 21 tenths what? Feet per second per second. Oh, okay. Well, let's look. Look at D. Is the speed of the car increasing or decreasing at t equal 40? What do you have to know to determine if speed is increasing or decreasing? The signs of the velocity and acceleration. V of 40 is what? V of 40 is positive. V prime of 40 or A of 40 is negative. So the speed, since V of 40 and A of 40 have opposite signs, the speed is decreasing at time 40. Good. Well, we might have a shot here. Next page. All right. You might want to assign yourself to Encore tomorrow. Okay. Now this is part of the 2000 exam. Two runners, A and B, run on a straight track for 10 seconds. The graph below, which consists of two line segments, shows the velocity in meters per second of runner A. So this is for runner A. The velocity in meters per second of runner B is defined by this equation. So this is B's velocity. So we're given an equation for B and we're given a graph for A for their velocities. All right. Find the velocity of runner A and the velocity of runner B at 2 seconds. Let's do A first. I need the velocity of runner A at 2 seconds. All you can do right here is approximate, correct? Roughly. We're going to find it exact. Oh. How, you ask? I can write the equation of that line, can't I? Well, because I have 2 points. And if I find the slope of that line when, never mind. What is the slope of that line? So, 10/3, I agree. Can you write the equation of the line? Y equals 10/3 t. And I really could put this, couldn't I? Plus what? What's the y-intercept? Are you okay that that's the equation for the velocity from 0 to 3? What is the velocity at time, what time? 2? Aha. So V of 2 is 10/3 times 2, or 20/3. What's my unit here?
That would be
Meters per second. Here, that's right, here, in those first 3 seconds, your velocity is always going to be, well, 10/3 times your time. What happens right here? See, your velocity is increasing here. What about your velocity here? How can you have a constant rate? In a car, you would put on your cruise. So they just went into cruise control mode while they were running right here. Okay? They were so far ahead after 3 seconds, they were just able to cruise in. Okay. What is the velocity of runner B? How'd you do that? Plugged what into what? So for B, and this is for A, so for B, V of 2 is a plug and chug, 48/7. Do you have questions? Yeah. I'd rather you not, but you can. You can. When I am grading your tests, I want sentences. The AP exam will not be looking for sentences. They'll be looking for the units. They'll be looking for the number, and did you use your units correctly? But I want a sentence, okay? But not on the AP exam. Find the acceleration of runner A and the acceleration of runner B. Let's talk about runner A. You know the equation for the velocity of runner A, right? Well, I only want to find the acceleration. Do I want to write the equation? I don't know. Let's see. Yep. So what is A of t then?
Whoa, wait, whoa, sorry.
Just 10/3. So what is A of 2?
10/3.
10/3. This has constant acceleration. Constant acceleration. That's fine. What about runner B? Ha! I forgot units. Meters per second per second. Yeah. Now I heard for runner B, quotient rule. Yes. But what was that? But what's wrong with the quotient rule? Because you got to do minuses. All right. I'm going to look here so I don't have to keep scrolling back and forth. So for runner B, A of t, which is V prime of t, is derivative of the top. I got to have some more room. Times the bottom minus the derivative of the bottom times the top over the bottom squared. What did I do wrong? Oh, this is a plus? Oh, okay, thank you. Please just plug into this. Please do not take the time to do algebra here and distribute and combine like terms, because all you want to know is A of 2. So just plug it in. Plug it in. So A of 2. What's that? 24 times 7 minus 2 times 48 over 7 squared. $72 over 49. And then remember your units. Now I'm going to tell you a little secret. You hear a little secret? On the AP exam, not in my class, but on the AP exam, you could leave that and put your units behind it.
What?
That's a safe stop.
Are you serious?
On the AP exam, that's a safe stop. Yeah,
Bigger class, like first
I promise, that's a safe stop.
rule change.
No, that's a safe stop.
That's skeptical.
You would have to make sure you put your units, okay? All right, 2002, number 3, partial. An object that moves along the x-axis with an initial position, x of 0 equals 2. I want you to understand something. This right here, we will use that later on because this is only a partial. Using that is not in what we're going to do here. Initial position is critical. What that tells me right there is that at time 0, I'm not at the origin. I'm already somewhere. I'm already at 2 feet or 2 meters. That's not going to be part of this because you haven't learned how to deal with that yet. The velocity of the function is given here. And remember, we're time 0 or bigger. What's the acceleration? Let's do this by hand, shall we? It's trig, so I want you to remember how to do. Yep. What's the derivative of sine? Cosine. So this is cosine of pi over 3 t times pi over 3. So not negative. Yeah. Derivative of cosine is minus sine. What is the acceleration at time 4? Oops, I've got an a prime of t there, and I shouldn't have an a prime. That's a. Can you do that?
Oh, it's going to be the negative.
It is negative. It is negative.
Negative 1/2. Negative pi over 3.
Oh, it's third.
What quadrant does that end up in? The third quadrant. What's its reference angle? Good. That's what they're learning how to do right now. Okay. What's the cosine of pi over 3?
Negative, wait, no, 1/2. 1/2.
Cosine of pi over 3 is a half. In quadrant 3, negative 1/2. Yeah. So this is pi over 3 times negative 1/2. Is that negative pi over 6? That's your, huh? If it didn't give you units, don't put any.
Oh, so you don't have to put
Nope.
units.
You do not have to put units per, no, you do not have to do that. Consider the 2 following statements. For 3 to 4.5, the velocity of the object is decreasing. And statement 2, for t between 3 and 4.5, the speed of the object is decreasing. Now, let's be careful. On this one, I'm looking for velocity, and on this one, I'm looking for speed.
Oh, no.
We good? Okay. Okay. All right. The first thing I want you to know is why were these picked? If I let t equal 3, what's that? If I let t equal 3, what's that? Pi. If I let t equal 4.5, what's that? 4.5 would be 9/2, right? Times pi over 3. Say again? 3 pi over 2. So this takes us from pi to 3 pi over 2. What quadrant are we in then?
3.
From pi to 3 pi over 2. So we're talking about quadrant 3. I just want you to don't get just all bent out of shape about that. Okay. So, remember, in all of quadrant 3, cosine does the same thing. Cosine is negative. In all of quadrant 3, sine is negative. Okay? Is the velocity increasing or decreasing? Velocity. What is the velocity at what was the velocity at time 4? We didn't figure that out, did we? Now, but velocity is decreasing f prime. Okay, let me go backwards. A function is decreasing if its derivative is negative. Velocity is decreasing if acceleration is negative. Is acceleration at 4 positive or negative? Negative. So is velocity increasing or decreasing at 4? Decreasing, because 4 is on that interval. Then, well, yeah, but what that tells me is that since 4 is on that interval, then I know that what I'm talking about is in quadrant 3. So all of quadrant 3 behaves the same way. You would have gotten a negative in all of quadrant 3. So what are you going to say here for statement 1? True or false? So statement 1, you're saying is true. Why? A of t is negative on that interval. So v of t is decreasing. You got that? Now, last thing, look at statement 2. Statement 2. Is the speed of the object decreasing? I know the equation for the velocity though, right? What is v? Aha. So this would be sine of 4 pi over 3, right? That's negative. So I know v of 4 is negative. What's v prime or a of 4? Is negative. So speed is increasing since v of t, since v of 4 and a of 4 have the same sign, therefore, what do I know about the statement? Statement is false. One thing. Here, I wrote here, and on this one, I wrote that, right? It probably would have been better on this one if I had just put at. It probably would have been better if I had just put a of 4 is negative. We're finished.